Hi, see you again, everyone. This time, we would like to discuss document processing and document properties. The agenda for this meeting will be the basic properties, and then we will discuss the information retrieval model, then followed by processing steps on the information retrieval model, and then we will discuss the Boolean representations and Boolean retrieval model. Next, we will continue with the discussion on the vector space retrieval model, and then followed by cluster-based retrieval model. We will close this meeting with performance evaluations and briefly mention other processing document applications before we are discussing the next assignment. Okay, so the generic process is displayed here, just like before. The generic process include the acquisitions, pre-processing, segmentations, feature extraction, feature selection, and feature matching. So as with other data types, the process consists of two main phases. One is the reference building or database building or training phase. And then the second part is the deployment phase, which for information retrieval, it could be set or often known as information retrieval phase. Okay, so the step is we start with acquisition, where we have a text collection or collecting the text that we would like to process, or there could be a corpus of the data that we would like to process. And in some other case, we have to do a web scraping to obtain document from the web or from social media such as Facebook, Twitter, and so on. And then we do some pre-processing to remove noise. Noise here means any information that we do not really need for our data processing purpose. And we will see later on what kind of an acute noise removal we could do. And then we might want to normalize text, known as text normalizations, such as when we have number 17, we might want to convert it into text 17 or 17. And then we'll discuss about the segmentations, or the next step is will be segmentations, where we segment the documents into word, phrase, and so on, followed by feature extraction. So a word might not the features that we want. We want to extract the features from the word, which is normally a term or a stem. So we have a term frequency, which is the number of occurrence where the terms appears in the document. And also we have the what is called the FIDF. This is a weighting scheme for a term. We give a weight to a term based on the number of the appearance of the terms in a particular document and how many documents consist that terms. So if that particular term appears only in one document, then it would be very specific, and so the weight for the TF-IDF scheme is high. Then we have a sentiment where we say, for example, if somebody looks like happy with something or supporting something, for example, in the presidential elections, who is likely to support candidate A and who is likely to support candidate B, etc. So then we'll continue with the feature selections or term selections, which one we do, we really need the term and which one not. And then at the last part, we will do or discuss some matching. This could be include the template matching, vector space model, Boolean retrieval model, and then the statistical, which could also be on the vector space model, and then it could be done also using the artificial neural network approach. So the basic properties of a document includes the paragraph. So a document consists of paragraphs, paragraph consists of sentences, sentences consist of words, and words also, there could also be numbers and special punctuation mark for the sentence, like point, comma, semicolon, colon, a quote, etc. Now, note that this particular mark may not be needed in our processing, so we could remove them. So we could consider them also as noise if they don't contribute anything to our applications. Opposition may also be considered as the property. For example, we would put more weight on words on the title, so that the title will be considered separately, or we will consider the title specifically, and then also subtitle and paragraph and so on. And so we might also consider the abstract as having a special weight. So the basic features, then from the words we could extract the terms and term frequency, which says that this term appears in how many times, and then the term locations, which signify which term appears in which paragraph, what sentence, and what is the sequence of the term in that particular sentence. Okay, so now we will discuss about the information retrieval model, or IR model. Basically, we could divide the model into two parts side by side. The left one is the part that is working or used when the model has been built to query informations, and then the one on the right is when we are building the model. So you could imagine this one something like the Google applications, where we can put a query to Google, and then the Google will process the query. Somehow the query representation is inside Google, we don't really know what it is, and then the Google will retrieve some document from us based on the similarity calculations that is carried out inside the Google machine. On the right is the Google site in this example, where Google collected so many documents from the internet by scraping the internet, indexing. So Google will process that document from the internet and then represent that document in a particular representations. And so whenever there is a query, then the query is processed and then matched with a particular matching algorithm, and then the document match is given to us as the user of the Google search engine. And then we could do some relevant evaluations on our site, and if we think that the answer of the Google engine is not really relevant, then we could reformulate the query. However, the other feedback can only be done by Google, such as the document feedback to the document representation, this one, and also feedback to the query representation. Now we could look at the a little bit more detail of the processing on the previous transparency. So the input could be the query that we give to the machine, like Google search engine. It could be a document in the case of, for example, we have a document and we would like to know if this document is similar to other documents. And so this one is an example of the plagiarism detection. And then the machine, the application will do some processing. If we propose the method, then we do some processing for that, which includes document parsing or query parsings. We might need to remove some stop words. We will see later on what kind of stop words we could remove. We want then to follow with stemming. In this case, stemming is removing the infix, suffix, and prefix. And then from the stem word, we might want to calculate the term frequency or the number of appearance that term appears in particular document. We might also want to replace some terms with common terms. For example, learning might be replaced by study, etc. And then followed by the document representations, which is sometimes called indexing. We could use the inverted file formats. We will see later on what inverted file formats looks like. And then also we could use vector space model. So the representation is in a vector space. So it means that our document is represented as represented in a vector space. So as a point in a multi-dimensional space. And then we have cluster-based model. So in this case, our document is also a point, normally in a cluster and a vector space model, but each document belongs to a particular cluster or particular groups. And so whenever we process the query, we could compare our query with the groups rather than with individual documents. Even though then we might want to look at the individual document inside the group. Now, then we will continue with similarity calculations to measure the similarity between the query and the document which is on our corpus. Now, We could, of course, use the Boolean similarity measures, but we could also use the cosine coefficient measures. Now we will also see this one, these two, followed by relevance evaluation. So if you do, for example, your final project, you might want to measure how good is your method. Now we could measure, for example, using precision or using recall. Now for a more complete discussion on the relevant evaluations, we will discuss that later on in the course. So based on the similarity calculations, then we output the document with match the input query. Okay, so this is a little bit more detail on this discussion. So we identify word in the title, abstract, and document. Eliminate stop words. So the stop words may include as, are, the, of, a, etc. These are the high frequency function words. Now, please be in mind that for any language, it has its own stop words. So if your document is in Bahasa Indonesia, then you would want to build a stop list specific for Bahasa Indonesia. The same thing if our document is in Bahasa Jawa, is in Javanese language, then our stop list will also be specific for that language. Now, after removing the stop words, then the number of terms in our document will be decreasing significantly. Now, we might want to continue reduce the number of terms by identifying words with synonyms, and then we might want to remove that with a common word. So, for example, if we have a word study, learning, schoolwork, reading, and so on, it might be replaced with study. Now, of course, the detail whether we want to replace this or not, it really depends on the application that we are developing or the method that we are proposing. Now, after that, then we have fewer terms. We could still reduce the number of terms by stemming the words. Okay. So, for example, we have a word here, retrieval. Just remember that stemming means we remove the inflectional affixes. We remove the prefix, we remove the infix, we remove the suffix to build a root word, or we will cut the word or stem to a common string only. So this is an example below here. Is an example where we cut the string, a word retrieval, retrieving, and retrieve to become one word only, retrieve. Now, of course, if there is one retrieval, one retrieved word, one retrieving, and one retrieve, then the frequency of the appearance for the word retrieve, the last one here, would be 4. Okay, so the term frequency might be increasing, but the number of terms or word is decreasing. Okay, and then we count the stem frequencies in each document. So again, if the number of appearance of a particular stem or term is 5, then we add 5 as the frequency of appearance. Then we calculate the weight, and the way we calculate the weight might be based only on the occurrence. For example, if a particular term appears only once, then we could say that the weight is 0.1. If a particular term appears 5 times, then the weight is 0.5, and so on. Now we could also determine the weight based on the occurrence or the appearance on a particular document, and also the number of documents where that particular word appears. So this is the scheme of the TF-IDF, which we will discuss later on, how to calculate the weight using the TF-IDF. Okay, so then we create document representations. Again, we could use inverted file or vector space, and then we do some feature matching or similarity measurements, which means that we measure the similarity between the two documents, the input and the one in our corpus or the query with the corpus. We could use the cosine coefficient or Boolean operator for matching the similarity. Sorry, for similarity measurement. Okay, then we will measure how good is our method by measuring the recall and the precision of our method. Okay, so again, I repeat that the document features method terms and then might be weighted terms, where the weighted terms might consider only the appearance or the number of occurrence of that particular term, but it could also be using the TF-IDF scheme. Now the weight of a particular document in document I, the term is term number J in document I, is calculated as TFIJ, which means TFIJ means the number of occurrence a particular term J appears in document I, multiplied by the logarithm of M divided by DFJ. So M is the number of documents in our collection, in our corpus, and the DFIJ is the number of documents where a particular term appears. So, for example, if we have a corpus of 1,000 documents, and then we have a particular terms, let's say it, okay, this particular term it appears in, let's say, 10 document. So in this case, M is 1,000, and then it is the term J, term number J, and then 10 is the number of occurrence of the term it. Let's say that it appears 5 times in a particular document I. Okay. The width would be the term frequency is 5, so 5 multiplied by log 1000 divided by 10. 1000 divided by 10 is 100. Log 100 is 2. 2 multiplied by 5. So the width would be 10 also in this particular example. Okay, the term could be an opinion or words which has an opinion on it. The opinion will might be categorized into supporting or agree, disagree, and could be neutral. So, for example, a word which indicates that someone is supporting a particular candidate, or it is against particular candidate, or it is neutral, and so on. Okay, now we start with the first retrieval model, which is the Boolean retrieval model. Okay, so the representation for the Boolean retrieval model is normally an inverted file. So in this example, I will start with the example. We have term number 1, term number 2, term number 3, and term number 4. The way we represent the document is that term number 1 appears in document number 1 and document number 3. It doesn't say anything about the position in that document. It simply says that term number 1 appears in document 1 and document 3. So this is the basic inverted file. Okay. Now term number 2, it happens to appears in document number 1 and document number 2. So it means that document number 1 has term 1 and has also term 2. And document number term number 3 appears in document number 2, number 3, and number 4, whereas term number 4 appears in document number 1, 2, 3, and 4. Okay, so that's the way we represent the document in an inverted file. Now we could extend that representation into the form in the following form. So, for example, we have a word information and a word retrieval. The word information appears in document number 99 and document number 155 and also document number 166. In document number 99, the word information appears in paragraph 10 here, sentence number 8, and word position number 3. Now the word retrieval likewise appears in document number 99 also, in paragraph 10, sentence number 8, and sequence of word number 4. So if there is a query saying that I would like to have information retrieval within one sentence, then the answer would be record number 99, because this is the only document which contains the word information and retrieval in the same sentence. The retrieval and information also appears in document number 165 here. However, information appears in paragraph number 2 and retrieval appears in paragraph number 10. So they must not be of the same sentence because they are on different paragraph. Now, we could also have another kind of inverted file, which is we are putting the weight or adding the weight to each term. In this case, let's consider that these are only based on number of occurrence. If a particular terms appears on a particular document once, then the weight is 0.1. If appears 3 times, then the weight is 0.3. So for example, here term 1 appears on record 1, the weight is 0.3. So it means it appears 3 times on record number 1. Now remember also that we might use different weighting scheme. For example, any word appears on a title would be given a weight of 0.3. So that is possible if we would like to have that kind of weighting scheme. Okay, so now for the retrieval and the Boolean retrieval model, we could use the operator AND, OR, and NOT. But the way we write NOT is using the word AND NOT. So term I and term J means that we want to retrieve document which has term I and term J in that document. The second statement, second query means that we want any document which consists of term I or term J. So any document consists of term I only would be retrieved, and also any document consisting of term J only would be retrieved. And if it contains term I and term J, it would also be retrieved. Now, if we have a query term I and not term J, then the document that will be retrieved is document which consists term I, but in that particular document does not have term J. Okay, now in a weighted term, then if we have an operator of AND or not, the way we calculate the similarity is like this one. We use the higher weight for OR. We use the smaller weight for AND. And we use the difference of the two weight for NOT. Okay, this is not an example. Well, it should be an example. We have term 1 and it appears on document number 1, document number 3, document number 6, and document number 7, and document number 11. The weight for the term 1 is 0.3 in document number 1, 0.5 in document number 3, 0.8 in document number 6, and so on. Term 2 also appears on document number 2, document number 3, document number 7, and document number 9 with different weights. And we also have term number 3, which appears on document number 1, number 2, and number 9, also with different weights. Now let's suppose we have this query. Okay, term 2 or term 3. Now we have from R1, we have from R1. Remember that our query is using an operator OR, which means that we will take the higher weight. Okay, term 2 or term 3, term 2 appears in document R1. So term 2 or term 3 appears in document R1, which is the term 3, and the weight is 0.8. So we record here R1, the weight is 0.8. Term 2 appears on record number 2, and the weight is 0.7. So then we have R2, the weight is 0.7. Term 3 also appears on record number 2, but the weight is only 0.4. So we take the higher weight. And then term 2 appears on document number 3 with a weight of 0.6. And then term 2 appears also on record number 5. Document number 7 with the weight of 0.5. And then term 2 also appears on document number 9 with a weight of 0.5, and document number 9 of and term 3 appears on record number 9, document number 9, with a weight of 0.7. So we take only the one with the higher weight, so we say R9 0.7. Now the output is arranged based on the weight in decreasing order. So what appears first, the first rank would be R1 with 0.8, the weight is 0.8, and then R2 with the weight of 0.7, R9 also the weight is 0.7, and then R3 the weight is 0.6, and R7 and the weight is 0.5. Okay, now let's consider the second query. We have term 2 and term 3. Now, because the operator is n, and so we are taking the smaller weight. So term 2 and term 3, basically the query is almost is like on the first example, except that the operator now is an n. So term 2 and term 3, so we are looking for document which consists of term 2 and term 3. So the document which consists term 2 and term 3 are document number 2. One is the weight is 0.7, and the other one the weight is 0.4. So we record only the one with the weight of 0.4. The other document would be document number 9, and the weight is 0.5 and 0.7. So we record only the lower weight, which is 0.5. And so the output of the query is record number 9, comma, it should be comma, not n. Record number 9 followed by record number 2, or document number 9 followed by document number 2. Now the third query says that we want to have document with term 2, but there is no term 3. So term 2 only. So the term 2 without term 3 would be record number 3. Sorry. Sorry. If the operator is AND not and we have a weighting scheme, then the way we process is it consists of term 2 and term 3, but the weight is the difference between the two. So term 2 and also term 3, for example, appears on record number 2. The weight is 0.7, and term 3 appears on record number 2 also, but the weight is 0.4. So we record the difference of the weight, which is 0.3. So we record R2, but the weight is 0.3. Now record number 3, the weight is 0.6. Okay. Term number 2 appears on record number 3 and the weight is 0.6. Term 3 does not appear on record number 3. It is actually the same as if we are saying that term 3 appears on record number 3, but the weight is 0. So the difference between the weight of 0.6 and 0 is 0.6. So we record R3 is 0.6. And now R7, it has term 2 only and the weight is 0.5. And the same case as record number 3. And then record number 9, the weight is 0.7 and 0.5. So the difference is 0.2. And so the retrieved documents are record number 3 because of the weight of 0.6, record number 7, the weight is 0.5, and then record number 2. Oh, sorry, I forget. There is a record number 9 also. The record number 2 and then followed by record number 9, because number 9 also appears on this. Okay, so you can add here R9.